All right, so I just want to take a minute to go over two of the homework questions you may have struggled on, which are numbers 10 and 12. So the directions on this was to find all roots. So the first thing I would try to do is try to factor and see if it is factorable. So we could take out a 4x squared. We could take out a negative 2. So because these are not the same, that tells me it is not factorable. That does not mean it's not solvable, it means that it's not factorable. Okay? So we then need to list our possible rational roots, which remember are factors of the last term over factors of the first term. So factors of 10 are plus or minus 1, 2, 5, and 10. Factors of 4, plus or minus 1, 2, and 4. And then we actually want to go ahead and figure out all of the possible rational roots by dividing. So we should get plus or minus 1, 2, 5, and 10. That's if I divide everything by 1, nothing changes. Now if I divide everything by 2, I'll get 1/2. I'll get 2 halves, which is 1. I'll get 5 halves. And I'll get 10 halves, which is 5. So I already have that written. Now we go to the next term. 1 divided by 4, we'll get 1/4. 2/4, which is 1/2. 5/4, which we don't have written. And 10/4, which would reduce to be 5 halves. So these are the possible rational roots. So now we need to go to our graphing calculator. And in my graphing calculator, I'm going to press my y equals button and I'm going to type in my function, 4x to the third. And you can either use your graph or your table. So I'm going to go to Zoom 6 and see if I can notice any of these that it goes through. And we should see that at negative 1, 2, 3, 4, 5, it is going through perfectly. We can always check by the table. Right now my table I have set to input the values. So let me test negative 5 and I do get 0. Alright, we could also test the other ones if we wanted to, like 1/2 and 5/4, but I will tell you that this is the only one that works. So now we are going to use synthetic division to divide out the negative 5. So we'll put negative 5 in our box and we will put our coefficients, 4, 16, negative 22, and negative 10. We will divide this out, which it should come out evenly to get a remainder of 0 if we do this correctly. 4 times negative 5 is negative 20. Remember, we add downward to get negative 4. Negative 4 times negative 5 is a positive 20. Adding down, we get negative 2. Negative 2 times negative 5 is a positive 10, which gets me a remainder of 0. So now we put our variables back in. This is now 4x squared minus 4x minus 2. We now need to solve that. The first thing I would probably do is take out a GCF. I can take out a 2. And then we need to use the quadratic formula. This is now my A, my B, and my C. So we will do the opposite of B, plus or minus the square root of B squared, minus 4 times A times C, all over 2A. So we'll get 4. We have negative 4 times negative, or times 2 is negative 8, times a negative 1 will be plus 8. 4. We then need to reduce the radical. The square root of 12 will break into 4 and 3, which will get me 2 square roots of 3. And then our outside numbers, 2, 2, and 4 are all reducible by a factor of 2. So I will get 1 plus or minus the square root of 3 all over 2. And I'm also going to bring down my other answer and put it down here, which was negative 5. Together, those are my 3 answers to the problem. All right, let's take a look at number 12. All right, number 12, you can see, is a quartic polynomial. So this is not going to be factorable by grouping because you can't group it into two terms. So we're going to go straight to listing our factors, our possible roots. And again, sometimes you can get away without doing this just by looking at your graphing calculator. Actually, let's try that. Let's go to our graphing calculator. Let's type it in. 9x to the fourth plus 3x to the third, because the directions did not say we have to list them like they did at the beginning of the assignment. So if you don't have to list them, sometimes you can use your graphing calculator and find some answers on your own. So it looks like it goes through at 1 and at -2. And then obviously this answer as well, but it's not a perfect number. It's going to be some sort of decimal fraction or square root. All right, so let's check and see. Again, my table is, I'm able to input it. If anyone needs to change their table, you press second table set, and you go down to independent and change it to ask. That allows you to type in any numbers that you want, or you can change it back to auto, whatever you prefer. So if I go back to auto, I can now see that it clearly does happen at -2 and +1. These are actual roots that work. So since we have 2 of them that work, we're going to do synthetic division 2 times. It doesn't matter which one you pick to start with, but we're going to use synthetic division twice. So I'm going to start with the 1, and I'm going to list out my coefficients: 9, 3, -30, 6, and 12. And we're going to perform synthetic division, bringing our 9 straight down. And again, we should be getting a remainder of 0, which we have done. Now, if you put the variables back in, this is going to be our constant, linear, quadratic, and cubic. You cannot factor a cubic yet. So what we're going to do is we're actually going to take the other factor and we're going to use synthetic division with this answer. Okay, so just kind of put another little box with your -2, and you're going to use your answer as the coefficients for the new polynomial. So draw another bar, and let's come down the page. 1 times -2. All right, so now let's put our coefficients back in. Or, excuse me, my variables back in. So this will be 9x squared minus 6x minus 6, which we can take out a GCF at least of a 3. And now we need to use the quadratic formula. So I'm going to do that part over here. So we will have -b plus or minus the square root of b squared minus 4 times a minus c. If you didn't factor out the GCF, you can use 9, -6, and -6 as a, b, and c. It will just be larger numbers at the end. All over to a. And so we will get -12 times -2, which is a positive 24. Oops. Should get 28. It's a little messy. I'm just going to fix that. We need to reduce our radical. So we'll break the 28 into 4 and 7, which will get me 2 plus or minus 2 square roots of 7 all over 6. And last but not least, we can reduce the outside numbers by a factor of 2 to get 1 plus or minus the square root of 7 over 3. And then don't forget about the two answers that you found up in the top. Bring them down as your final answer, so that should be -2, comma 1, comma 1 plus or minus the square root of 7 over 3. Remember, double check 1, 2, and then this is 2 answers because of the plus or minus, which gets me 4. So know that I have completed the problem. I hope that helps.